Evolution is a scientific theory, which means that it has lots of evidence to support it through discoveries and rigorous testing. The theory of evolution basically goes as follows. All species were once the same single-celled organism that throughout time slowly changed. This change was caused by random genetic mutations that proved to be advantageous to their environment. Because these traits were useful, it meant that if you had the trait, you were more likely to survive and pass on the trait to your children. This slowly created more and more different species, each with their own complexities. Evolution therefore has a complicated history between species creating different kinds of evolutionary patterns. These different patterns are divergent, convergent, and parallel, which is summed up as later generations of species slowly changing, later generations of different species becoming increasingly similar because of the environment, and later generations staying similar despite being different species. So how did the theory of evolution start? Well, the idea of where we come from has existed for thousands of years. However, the first time someone had an idea similar to the theory of evolution that we know today was in 500 BCE, when Greek philosopher Anaximander suggested that humans must have originated from fish. His reasoning was that because our children are so dumb and defenseless, there must have been a time when our offspring could survive on their own. Why did he decide we came from fish? No idea, but he was surprisingly accurate all the way back in 500 BCE. So naturally, with such a good idea, what did everyone else do? They forgot about it for 1700 years, of course. The year is now 1237, and a Persian author, Nasir al-Din al-Tusi, believes animals can gain differences from their environment. Which is another pretty close idea, right? Anyway, 500 years later, and Carolus Linnaeus develops a system for naming organisms which seems to begin piquing the interest in biology, because the next 100 years are filled with new ideas and scientific notions that help shape our current theory of evolution.
3, 2, 1, go!
This guy has the basic idea that species can change, but doesn't think new species can form. Not much new ground being covered. This guy thinks we come from primates. This guy begins talking quite explicitly about evolution, natural selection, and a basic concept of homology. However, he publishes it all in poetry form to avoid criticism. This guy points out that fossilized animals look a bit different to the animals we have today. He thinks something probably happened for this change to occur. This guy comes up with the idea of evolution, which is remembered as the typical misconception. You must be really insecure about your height if you think stretching enough means your children will be taller. These two use misconception man and poetry person's ideas to try and connect plant and animal origins. This guy looks at how the Earth's shape must have been created slowly by geological change, and he thinks maybe animals changed with it. This guy gets on a boat. Wonder why that's important. Anyway, this guy pioneers a new branch of science called ecology to get more people talking about species and their environments. This guy comes up with a theory on evolution. Oh hey look, it's Boat Guy, and he's also got a theory on evolution. Looks like he decided to team up with that last guy to write the theory of evolution down in a book called On the Origin of Species. This guy publishes a very important report that establishes genetic inheritance, which of course, you guessed it, goes unnoticed for 40 years. This guy connects evolutionary theory to embryology, creating a new branch of science called evolutionary developmental biology. No one wants to say that though, so they all call it Evo Devo. This also leads to a guy singing a song about it in like 150 years, which I don't understand at all. A bit later, Boat Guy writes some more books. Then this guy thinks evolution works for behaviour as well as physical traits, and gets an effect named after him. This guy makes up some new terms for us to use, such as gene. Then this guy begins experiments with fruit flies, which reveals evidence supporting the laws of inheritance. The next 80 years are then filled with a whole bunch of scientists publishing scientific papers and finding more and more evidence to support evolutionary theory. A few notable moments are in 1953, when the work of these three allowed for the discovery of DNA chemical structures. In 1974, we find the famous human ancestor Lucy. Then it takes us from 1975, where we find that chimpanzees share 99% DNA with humans, all the way up until 1984, when we realised that means chimps are closer related to humans than they are gorillas. Then, in 1997, we sequence the human genome, which leads to a whole bunch of genome sequencing, including the Neanderthal genome in 2010. As you can see, scientific discoveries have become quite frequent and convoluted because of the sheer amount of people working on them. So surely, if there's this many people working on them, then there has to be some work that's done in Australia. Well, a scientist named Scott Kioff has used evolutionary theory to research molecular phylogenetics, phylogeography, biogeography, and systematics of Australian frogs and reptiles. In fact, he is the CEO and teacher of Kioff Labs, which is based in the Australian National University, Canberra. But what's in store for the future? Well, everyone makes it seem like the only things in store for the future are climate crises and robots. So let's focus on the less depressing option. Well, probably the less depressing option. Human innovation is really just us borrowing ideas from nature, and we're no exception when it comes to AI learning. There is a specific type of machine learning that is an entertaining mix between the Baldwin effect— No, we're not doing that again— and training your pet. This method is called the reinforcement learning method, and it has already been used for social media algorithms, physical robotics, navigation, and video games. The basic premise of the method is to first create a set of actions that the AI can perform, introduce the AI to its environment, whether this be inside a game, a social media platform, or even a simulation of a real-world environment. Then, create as many copies of the AI that the computer running the environment can process. Having all these AI then complete a set amount of random actions, you can then take the best bunch according to parameters previously set which state what is beneficial. This selected bunch will then be used as a baseline for the next generation of AI copies, which determines what kind of random action the AI should attempt. I personally think that this multi-generational method is a very clever use of evolutionary theory, having all the elements such as mutations in the forms of random actions, survival in the environment as beneficial parameters, and the acquired behaviors over generations are much like that one guy's effect. I don't believe that this method will continue to be the primary method of the future, but there's probably a few more creations that will come from this form of AI learning, and if nothing else, there is an Australian YouTuber who makes some very entertaining content from them. So to sum it all up, evolution, mutation, overview, evolution, mutation, overview, evolution, this guy, that guy, this guy, this guy, evolution, mutation, evolution, AI, environment, AI. Thanks for watching. Hopefully you learned something.